to understand how matrices work and how they are used in calculation, it is very important to first learn about the different types of matrices and their basic properties. So these concepts form the foundation for further study of matrix operation and their application in physics and mathematics. So let us start off with types of matrix. So types of matrix. The first type of matrix being square matrix. So what is a square matrix? A matrix whose number of rows are equal to number of columns. A, B, C, D. This is a square matrix because here number of row is 2 and number of column is also 2. So it is a 2 cross 2 square matrix. Next variety of matrix being diagonal matrix. So what is a diagonal matrix? If non-diagonal elements of a matrix are all 0, then the matrix turns out to be a diagonal matrix. For example, if A is equals to A, D, rest all being 0, this will be a diagonal matrix for a 2 cross 2 2 cross 2 matrix. A diagonal matrix can also be A, B and C. This will be a diagonal matrix for a 3 cross 3 matrix, because here we have only the diagonal elements and rest all elements turns out to be 0. Now the next variety of matrix being scalar matrix. What is a scalar matrix? If all the diagonal elements of a matrix are equal, then it is a scalar matrix. For example, for a 2 cross 2, if all the elements of the diagonal are 1, 1, or if all the diagonal elements of a matrix are 2, 2, like they need to be equal. X and X, rest all can be 0. So it should be X, X and X, and rest all elements should be 0. So this is basically a scalar matrix. That is, here all the diagonal elements of the matrix are equal. Alright, now comes identity matrix. So what is an identity matrix? Identity matrix is a matrix whose diagonal elements are all equal to 1. Alright. So a scalar matrix with all diagonal elements equal to 1 is an identity matrix. So 1, 1, 0, 0 is a 2 cross 2 identity matrix. 1, 1, 1, 0, 0, 0, 0, 0, 0 is a 3 cross 3 identity matrix. Alright. Now the next variety of matrix being null matrix. So what is a null matrix? If all the elements of a matrix are 0, then we call it to be null matrix. For example, 0, 0, 0, 0, or 0, 0, 0, 0, 0, 0, 0, 0, 0. So this is a 3 cross 3 null matrix. Now we will basically talk about row matrix. So what is a row matrix? It is basically a matrix having only one row. So it can be A, B, C, dot, 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 but just one row. Now comes column matrix. Again, column matrix will be a matrix which have just one column, A, B, C, D, dot, 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 but the column being fixed to 1. Alright. Now comes our next variety of matrix, which is called upper triangular matrix. So what is it? It is basically if all the elements of a matrix below the principal diagonal are 0, then it is said to be upper triangular matrix. So all elements below the principal diagonal needs to be 0. Let us consider the principal diagonal to be ABC, and all elements above the principal diagonal will be non-zero. So it would be E, F, G, but then all elements below the principal diagonal needs to be 0. So what it is basically forming is just look at this. This forms the upper triangular matrix, isn't it? Isn't it forming a triangle in the upper section? So this is why it is named as upper triangular matrix. Alright. Similarly, now we'll look into lower triangular matrix. Alright. What is it? If all the elements above the principal axis are 0, then it is said to be a lower triangular matrix. So how is it? Here the criteria says that all the elements above the principal axis needs to be 0. So below the principal axis all the elements needs to be non-zero. So again, this forms a lower triangle, isn't it? Because the diagonal, the elements above the diagonal elements, above the principal diagonal are all 0. So the matrix is basically consists of elements below the principal diagonal, which forms a lower triangle. So this is why it is named as lower triangular matrix. Alright. Now we come to the next variety of matrix, which is called singular matrix. Alright. So what is a singular matrix? A matrix is said to be singular if determinant of A is 0. Alright. Coming to the next topic, which is non-singular matrix. What is a non-singular matrix? If determinant of A is not equals to 0, then it is said to be non-singular matrix. Alright. Coming to the next variety of matrix, which is idempotent matrix. So what is an idempotent matrix? It is a square matrix such that A square turns out to be A. Then the matrix is said to be idempotent matrix. That is basically a matrix whose square has the same value as itself. Alright. Now let us look at the interesting feature of this idempotent matrix? So let us consider A to be a idempotent matrix. So it will satisfy this above said equation that A square is equals to A. Alright. Now let us consider that if A inverse exists. Alright. So if A inverse exists, what we can do? We can multiply A inverse from the left hand side on both sides of this equation, above equation. So it comes out to be A inverse A square is equals to A inverse A. Now A inverse A, the above equation can be, left hand side can be written as A square can be split into 2A. So A inverse A and A is equal to A inverse A. Now A inverse A is nothing but I, right? Multiplied by A is equals to, again A inverse A is nothing but I. So again I into A turns out to be A. So A comes out to be I. So identity matrix is basically the only idempotent matrix. So identity matrix turns out to be the only idempotent matrix whose inverse exists. Else there are no other matrix whose inverse exists. That is, its determinant is equals to 0. So if determinant is equals to 0, then that matrix's inverse does not exist. Like for example, if determinant of A is equals to 0, then A inverse won't exist. So singular matrix inverse does not exist. Inverse exists only for non-singular matrix. So identity matrix is the only idempotent matrix which is invertible or whose inverse exists. Alright. So that's it for the properties of matrix for today. In the next video we will deal with transpose of a matrix.